This is Dutchess Community College, MAT 221. This is Mrs. Johnson. This is an example of finding the equation of the tangent line to a curve at a given point. Given this curve f of x shown here, we want to find the tangent line to the curve when x equals 1. So our answer is going to be a linear equation. We want the equation of the line that is tangent to this curve at the point when x equals 1. In order to do this, we first need to find the derivative of this function. But before we find the derivative, we need to simplify the function so that this last term can be rewritten as a simplified function using a power function, using our values that we learned, our rules for exponents we learned in pre-calculus. Now, term by term, let's find the derivative of this function. Pretty easy here. We get 3x to the 3 times 4 is 12x to the third. 2 times 2 is negative 4x to the first, and then negative 1 times x to the negative 2. The next thing we need to do is we need to find the value of the function at x equals 1 and the value of the derivative at x equals 1. Because we're trying to find the equation of the tangent line to the curve when x equals 1. By putting 1 into the original function, putting in 1 here to the original function, we get 3 minus 2 plus 1, which gives us a value of 2. Putting 1 into our derivative function we just found, putting 1 in here, we get a value of 7. We know the equation of a line. Again, from previous courses, we know that the linear equation is y equals x minus x1 plus y1, gives us point slope form of a line, which is the desired line equation that we want for calculus, that point slope form of a line. Here, we know that the slope is going to be the value of the derivative, which we found here. That's going to go in for m. Here is the x-coordinate we're looking at, and in this case we're looking at an x-coordinate given to us at x equals 1, and then whatever the y-coordinate of the curve was at that point 2, which we found was x equals 2. So putting it into this equation, the tangent line to the curve at x equals 1 is the line y equals 7 times x minus 1 plus 2. We can leave this as just in this form. It's actually the desired form of the linear equation because it tells us the slope of the curve and it tells us the point of tangency, which is in this case the point 1, 2. It's a desired way to have our linear equation. Now we could put this in y equals mx plus b form, but our desired form in calculus is in point slope form.